Hello, good morning or good afternoon, everyone. Thank you for joining us today. This is the Agroforestry in Action webinar series. My name is Gregory Ormsby-Murray, Outreach Coordinator with the Center for Agroforestry at the University of Missouri. This webinar series is a production of the Center for Agroforestry at the University of Missouri. We're very pleased today. We have, for today's presentation, Eduardo Somarriba from CATIEC, the Centro Agronómico Tropical de Investigación y Enseñanza in Costa Rica. And in just a minute, I'll turn things over to our speaker. Before we get started, just a few notes. This webinar series, the Agroforestry in Action webinar series, we host it about monthly, usually on Wednesdays at 11 a.m. Central Time. And please know that all past recordings, today's presentation included, are recorded and are available on our website for on-demand viewing. So one can go to centerforagroforestry.org and click on the webinar link and find not only all past recordings of past webinars, but also a schedule for future and upcoming webinars and other information. So please, I encourage you to visit our website, centerforagroforestry.org, and find out about upcoming webinars and other activities and resources of the Center for Agroforestry. So back to today's presentation, titled Analysis and Design of Coffee and Cocoa Shade Canopies. Our presenter today, again, Dr. Eduardo Somarriba with CATIEC in Costa Rica. Eduardo is a very renowned researcher in the field. He's studied biology and has a master's degree in tropical forest ecology and a PhD in agroecology from the University of Michigan. He's been an active researcher, educator, and advisor in agroforestry for many decades, 30 or 40 years. He's currently the head of the program on agriculture, livestock, and agroforestry at CATIEC, and a focal point for the CGIAR Consortium on Forests, Trees, and Agroforestry. That's called FTA. Well, Eduardo's current field of research is focused on the optimal management of trees on farms, that is farming with trees, and multi-strata agroforestry systems with coffee and cacao, and the production of timber on farms. He's provided technical advice to governments, development projects, NGOs throughout Latin America and the world. He's led various science-based development cocoa projects in South America and Central America. He has numerous publications, probably over 200 publications, including scientific articles, technical manuals, books, etc. And he's been a mentor for students and farmers and researchers alike in the field. So it's my great pleasure and a great honor for the Center for Agroforestry to have Eduardo with us today. So Eduardo, welcome. Please, the microphone is yours.
Thank you very much, Gregory. Thank you very much to all the participants. It's a pleasure to be with you today and to join this series of seminar from the Center of Agroforestry in the University of Missouri, and the leadership of Gregory and also Michael.
Yeah, thanks, Eduardo. I'm going to mute my mic. I should just mention that today's presentation will run about 40 minutes, and then after that, we'll have some time, maybe 15 minutes for question and answers. So thank you so much, Eduardo. Please take it away.
All right. So this is a great opportunity to meet you all. This is that part of the agroforestry community that is interested in multi-strata agroforestry system with perennial crops, coffee and cocoa in particular. This like unlike many other tree crops, these are short tree crops that normally are grown under the canopy of other trees. So that makes the relationship between the shade canopy and the crop itself a very important issue of management. And I've been working on this issue for more than 30 years now, and I appreciate the opportunity to have this seminar with you and share some of the lessons that I have learned over these several decades. This presentation that I'm gonna give to you today reflects the content of a recent paper that came out last year, and you will see in the presentation, in one of the last slides will be there, the reference, so you can take a look at that later. So let's get our hands on it. Let me see, how do I move this thing? What happened? I don't see it move. Okay.
Yeah,
there we go.
Good.
Yeah. As you all see, well, there are different ways of growing coffee and cocoa. We call them different typologies. About 6 of them, different broad typologies, have been identified in the literature, both in coffee and cocoa. I'll just give you some example here in cocoa, starting from no shade systems to different shade designs, like the typical cocoa with a service tree legume like the Residia Scipion, or you can replace the service legume for a productive plant. It might be either a timber species, like this example with Terminalia ivorensis in Honduras, or with coconuts. You change the species, you replace the timber for a fruit tree, in this particular case, coconuts. In Jamaica, coconuts are very important because of the hurricanes. You will not be able to have the same tree species in Jamaica because of the effect of the hurricanes. So coconuts and palm trees, better option because they bend very easily, don't break. So the selection of the species has to do a lot with the actual condition in the sites. Or you have mixed system that you can see in the lower left side of the slide, mixed shade canopies where you have trees, timber trees from natural regeneration, some Inga or Gliricidia trees planted initially by the farmers, then intercrop with fruit trees. So it's a mixture system. Or you have forest-like structure like this in the center of the slide, in the lower part of the slide, which is known as Cabruca system in Brazil, which you basically, what you have is the forest, is all the understory is clear, and then you remove about 50–60% of the canopy trees, and then you plant the crop under that remaining tree forest structure. And there is yet a 6th system we call successional agroforestry, cocoa agroforestry system, in which there is a successional stage in the cropping cycle of the crop. There's another paper that we publish on the Amazonian successional agroforestry system with cocoa. There are similar examples with coffee, like in this example in Turrialba, that you plant Erythrina puepigiana by stakes, and you prune them, actually polar them twice a year to regulate shade. As you can see on the upper left part of the slide, a plantation which is being pruned. The higher part of the slide, the trees are not being pruned yet, whereas all the stumps you see that had already been pruned. And this is the guy who is pruning them, very happy with the machete. You can change the service species by a timber species, like this eucalyptus coffee Arabica system in Costa Rica, or you can combine the timber with the Erythrina and have this 2-story system where you have the Erythrina, which provides you a flexible shade that you can manipulate by pollarding, and a less flexible shade, which is the timber species, as a second strata. And here, the only possibility you have to manipulate is basically the density and the selection of the species. In this particular case, Cordia aleodora, which is a very interesting one for several reasons. One is that it has self-pruning, so you normally have clean balls, very good for timber. But also very important is that the canopy itself goes very high above the ground, and that has implications on the shading patterns. And then the phenology is very important. So you can combine different species with different features to obtain different shade patterns in the plantation. You can have other more complex system like this kind of home garden situation where you grow coffee intercrop with oranges and bananas and some erythrinas. So it's a kind of polyculture system with 3 crops. Or rustic system like this in India, where you have a native forest, and then you do about the same, clean part of the forest, remove all the understory, 50–60% of the canopy trees, and then you underplant with coffee. So different typologies, both in coffee and cocoa. The central question always is, what is the best shading? What is the best shade canopy for coffee or cocoa? And when people know that I work on this, they always ask me, well, Eduardo, now that you are supposedly the expert on this, tell me what is the best shade for Costa Rica or for Nicaragua or whatever, or for Turrialba in particular. And I always respond to them, well, it depends. And you will see that this depends actually on the inspection of a number of variables. I think my counting goes to about 21, 22 variables that you really have to look at in order to evaluate and assess what is the best shade canopy that you should have at this particular location in this particular plantation. So there are no recipes. Every condition is different. And because there are no recipes, the only way to go about this is to have a protocol, to have a way of thinking about it, a methodology that make you pass through different stages of the evaluation so that you can have arguments to make decisions to favor one or another shade canopy design. So what we are going to talk about today is about a methodology that we have developed here in CATIEC over the last 20–25 years, and we have tested in many situations. And I think it's a reasonable one. So I want to share with you this protocol. That's why the title of the presentation goes into the analysis and the design of the shade canopies. To start with, we have to look at the shade canopy as a volume. It is a 3D object. And the idea here, or work as an agroforester, is to design the best occupation of this 3D volume. What species, what densities, what sizes, what management is the best one for the particular objectives of this particular farmer at this particular location. And you have to take into consideration different strata, the spatial distribution, the temporal distribution, and many other aspects that are part of the methodology that I will talk to more about. The methodology has really 4 big steps. You start by looking at what the farmers want from his plantation, and the typologies tells you part of the story about what they want. When you go to a plantation and you find it's only open sun plantation, well, the goal of this farmer is only cocoa. But if you go, or coffee, but if you go to a farm and then you realize that this guy is producing cocoa and timber, well, you have different objectives. So farmers' objectives are very important here. Secondly, you have to look at the plantation itself. By this, I mean, look at the crop itself. And there are a number of aspects that I have to look at because this particular situation, these particular variables of the cocoa or the coffee plantation itself has implication for the shade canopy. And at least there are 3 are listed here: self-shading, crop phenology, the spatial distribution of the tree cover, and so on. Once you do the evaluation of the crop itself, then you start looking at the condition of the site. And there are a number of variables that you have to look at there. Soil fertility, the water availability, you're in a dry zone, or very dry zone, or very humid zone. At what latitude you are, what exposure. If you are in slopey terrain, is this exposed to the north, the south? Which way is exposed? How big is the slope? How steep is it? Is there nearby vegetation that produces lateral shade? Is it a windy place or is it a cloudy area? So there are a number of size factors that has bearing on the selection of the shade canopy. And only as a 4th step, you start looking at the shade trees. And again, in the shade trees themselves, there's a number of things that you will have to check. You have to see the value of it, why farmers have it. what are the characteristics of the tree or the canopy, the phenology, the size of the tree, and so on. So in what follows, I will go a little bit one by one of these steps. When you start with step one and look at the objectives, we normally think of productive aspect. No? What do you want to produce from this? And we have to be aware that there's always two things in the mind of the farmers. I might be interested in specific goods. I want timber, I want fruits, or maybe some services. I have found farmers in Panama, in cocoa, saying that that tree over there is a terrible shade canopy tree because it's has a very dense foliage. However, I love it because birds come to it, or I like the flowering of this during the months February and March, and I love the way it sees. So you have to really be aware that objectives of the farmers are not always related to goods, but might be also related to services. Some trees are introduced there only because you want it for shade. So you will be looking at the characteristic of the canopy itself. If it is dense, if it is tall, what is the kind of foliage they have? It's a thin foliage of big leaves. It's a dense shade or it's a light shade. Or you want to look at the value because it is useful for timber or the production of firewood or the production of fruits, because for family consumption, some of those fruits I can sell and generate some additional income, or because the fruit might have value for nutrition, for example. We did this study in Central America looking at the composition, the fruit tree composition in the cocoa plantations in Central America, and then look at the nutritional value of those fruits to see how fruit trees in this cocoa plantation contribute to the nutritional security and nutritional quality of the food for this family. And we realized two things. One is that you have, because you have so many different species with different harvest periods, you have fruits almost year long. But in general, in Central America, almost none of these species were rich in folic acid, for example, which is a very important nutritional component, especially for young families with women that are in the reproductive stage, because it has to do something with the pregnancy. And there are a number of fruit tree species that are also very common in the area that have very rich sources of folic acid. So you can start thinking, well, why don't we bring more spondias into this plantation, because spondias can provide the folic acid that we don't have in the current shade canopy. These kind of things are really very important. Or you can start looking at some environmental values, like, can I contribute to the conservation of the biodiversity? And you can see in Central America, different countries with different designs can contribute differently to the conservation of biodiversity, looking at these different rarefaction curves. One of the important aspects in biodiversity conservation by the management of the shade canopy is that there are some limitations in the maintenance of climax species. Most of the species that you find in the cocoa plantation or the coffee plantations are long-lived pioneers, very common species, or even exotic species, but the number of climax species of the native forests are very few. And even in some of the systems like the Cabruca systems or the rustic coffee system, where you have a large number of native trees, many studies in the Cabruca system have shown that these climax species are really muerto viviente, how to say, the standing dead, or living dead, or standing dead trees, because they are unable to regenerate successfully in the conditions of the cocoa plantation. So when you take a picture, you see there are a number of species, but many of those species will disappear over the years because they will not be able to propagate and regenerate themselves in the shade canopy. So there is an issue when talking about biodiversity conservation in coffee and cocoa shade canopies, that these Climax species find it very difficult to maintain the populations in the current management. We have evaluated the contribution of biodiversity to biodiversity of the different shade canopy, comparing with different other land use systems and different taxa. Cacao and coffee plantation can harbor a number of different taxa. In particular, it's very interesting to see the case with bats. We realized that in cocoa plantations, bat diversity is higher in the cocoa plantation than in the forest itself. And the reason has to do with the fruits, because in the cocoa plantation, because of the fruits, you have all the bats that come from the disturbed areas that don't necessarily live in the forest. And also you have the bats that live in the forest that get out of the forest and go to the cocoa plantation because of the fruits. So when you monitor the biodiversity of bats in cocoa plantation, you might find even higher diversity of bats in cocoa plantation than you find them in the matrix, agricultural matrix itself, or in the forest itself. So very interesting. Different taxa will respond differently to the conditions provided by cocoa or coffee agroforestry system in terms of conservation of biodiversity. Carbon is now a very important issue. The design of the shade canopy also has very important impacts on the amount of carbon that you can store. You can see this example from Central America. These are different countries: Nicaragua, Guatemala, Honduras, Costa Rica, Panama. And you can see that depending on the design of the system, you can go from 30-something tons of carbon above ground biomass up to more than 70 in Guatemala. And that depends very much on how you select the species and how you manage the species, but also has some important bearing on the productivity of the crop itself. So the design of the shade canopy has direct effects on the amount of carbon that you can store. So those are objectives. The step two, once you have set up what the objectives are, is because I want to certify my plantation for carbon, then I have to think about carbon. If I want to have food security, then I look at the composition of the fruit tree species and so on. If I look just shade and so on and so forth. So we already have this clear. We talk to the farmer, have all the necessary information to figure out what this family wants from the cocoa or the coffee plantation. We go to step number two. We got into the plantation, and then we have to evaluate at least three factors: self-shading, crop phenology, and the spatial distribution of the canopy cover. Self-shading is very important, perhaps one of the most important factors. It depends very much on the shade that the same plant produces to the lower leaves. If you increase the density, then neighboring plants shade each other, the cocoa plants or the coffee plants. This is very important in coffee because we move from cultivating tall varieties to cultivating short varieties like Caturra, for example. And you move from typically planting 2,000 coffee bushes per hectare with the tall varieties to planting 6,000 or 7,000 coffee bushes per hectare. By increasing planting density, even with this smaller plant, self-shading increases. When you increase self-shading, then there is less need to have shade trees. And this means that you will not be able to produce timber or fruits or any other product from the shade canopy because the self-shading increases so much that the need for the trees is no longer that high. So it's very important to regulate self-shading. And self-shading has to do with everything that has to do with the crowding of the cropping itself. No? The pruning system, the spacing, the variety, the planting pattern, whether you plant square or this triangular planting, how much you can pack. The packing or the density management of the tree really influences directly self-shading, and this has bearing on the shade canopy itself. So very important to look at the self-shading. Then you look at the phenology of the crop, and this tells you more about how you have to regulate the shade canopy within the year. Every year, you have a phenology or cropping cycle, which is really a phenology cycle of the crop. And according to this crop phenology within the year, then you will try to adjust the shade levels to the crop phenology. For example, we know that in coffee and cocoa, when the fruiting season comes, you have to remove shade. I mean, it's the best time, at this time of the cropping cycle, or the phenological cycles, you want to have the lower amount of shade because flowering will be positively affected by light. And also because just after flowering, the phenology, the physiology of the plant means that after the pollination and the fruit setting, the development of the fruit itself will require a lot of carbon, and this carbon really requires a lot of photosynthesis. So you will try to have the minimum amount of shade from fruiting to the filling of the fruits, because this is the time where most of the carbon will be allocated to the fruits, and the plants need this carbon. So photosynthesis is very important. So you have to look at the crop phenology. People in Turrialba, for example, and here in Costa Rica, they delay or advance pruning at the end of the maturation cycle of the fruit, because you can accelerate the fruiting period with shade or without shade, and that can be a management tool to avoid conflict with land availability of labor. Coffee competes with sugarcane labor, for example, in some places here in Costa Rica. So you, in some moment of the month, certain months, you want to avoid this conflict, and then you delay pruning the shade, keep the shade for a longer time. So when the labor is released, then you prune, stimulate the flowering, the maturation cycle, and then you can use the labor available. So it's very important, the phenology. The spatial heterogeneity is also very important. This is perhaps one of the main failures that you can see when you go out to see coffee or cocoa plantation. There's a lot of heterogeneity in the spatial distribution of the shade canopy of this plantation. And this is bad because you want all the coffee or the cocoa plants to experience similar shading condition all over the plantation. You don't want spots with a lot of light and spots without light. So you really want an homogeneous canopy cover. This is something very important, and most of the studies shows that spatial distribution of the shade cover is not as homogeneous as it should be in most of the plantations that you find out there. Once you have finished looking at the crop itself, then you have to look around for the site conditions. There are a number of factors there that you have to evaluate. Fertility, the water level, if there's lateral shade, what is the latitude? How is the exposure? If I am in a slope in the terrain in the hills, is it cloudy? Are there winds? So you have to look at all these factors because they have direct implication on the decision of the shade canopy. For example, a common wisdom is that if I have a very good soil, I can work with very little shade. If I have poor soils, unless I have the money to buy the fertilizers, I need to have more shade because I cannot let the plant to be exposed to high intensity solar radiation with a poor soil. So you have to really look at this factor. No? Are you fertilizing or not? Is a fertile soil or is a poor soil? And this will have bearing on the shade levels. I always ask these questions to farmers and also to agronomists, asking them to fill this 2x2 table, looking at the relationship between shade and soil fertility. It's very easy to determine where to put the number 1 and number 4. We just say you have a high soil fertility, number 4 will be maximum yield, coffee yield or cocoa yields, the minimum will be 1. If you have a soil with high fertility and low shade, you have a 4, you have a high yield. No? You have a soil with low fertility and high shade, you have the minimum yield. But the other two scenarios, not everybody knows exactly where to put the number 2 and the number 3. And as you will see later, we did this with farmers. This is one of the things that the farmers know least of everything about shade. They fail most of the time in putting the numbers 2 and 3 here. So I leave this also as a question for you. Water. Water is also a very difficult problem. If you look at the gradient of waters, cocoa, for example, is cultivated in areas that range from 800 millimeters of rainfall in Venezuela to 6,000 of rainfall, 6,000 millimeters of rain in Costa Rica. And the question is, if you don't take into consideration cloudiness, does it matter how much water availability is, how much water is available? Does it matter in terms of the decision of shading? The Brazilians with coffee decided that it matters after you reach a certain critical threshold. If you have a lot of water, it doesn't matter you have the shade or you don't have the shade. When water availability decreases to a certain level, it's better to have shade because shading reduces evapotranspiration. The shade produces a larger little layer that prevents evaporation from the soil and so on and so forth. So there is the benefits of having the tree is better than the demand of water from the same tree and leaves still enough water for the crop to grow well. But when you reach a certain threshold, and this threshold has never been defined clearly, the demand of water from the tree itself is larger than the benefits of reducing evapotranspiration because of the shading or the lower temperature and the litter. And there is very little research on this. And when you look at the literature in the last 5-10 years, you have contradictory results. In some places, people recommend keeping the trees because it improves water availabilities. In other papers, they say get rid of the trees because they really affect negatively the crop. So there's an area of research that is not really well covered, and it's something that needs to be done more in the future, especially with the climate change condition. Lateral shading is very important. Hills, for example, has something to do with the shading. No? Latitude South, for example, you look at this plantation. This is about 8 a.m. in the morning. You can see that part of this hill is already exposed to the sun, but some areas will receive direct sunlight only 1 hour or 2 hours later. So the slopes can change dramatically how much light you can get during the day or during the year, and that affects how much trees, how many trees, how big the shade canopy should be, depending on whether you are in a exposed area or in the lower part of the slope where you have a fewer number of hours per day of light. So that depends very much. Lateral shading is also very important. Some planting system, instead of having the trees dispersed within the coffee or the cocoa plantation, they plant it in rows, and they have a kind of alley cropping system. Lateral shading is very important. It's not as effective as the homogeneous distribution because you will have more shade closer to the tree lines than the center. So it depends very much, but you can use the lateral shading to produce money, like this example here in, this is on Honduras, in Finca La Fia. These are line planters with mahogany. This 1 kilometer of this is worth, $1 million probably. It's very, very valuable. So you can have to compensate, the possibility of producing large amount of timber in these tree lines as opposed to the negative impacts that this may have on the cacao trees that are close to the tree line. Obviously, latitude and exposure are very important. The sun is moving, we know, depending on the latitude. If you are in the equator, you have some part of the year the sun more inclined to the south or to the west or to the north. But if you are in the northern latitude, for example, here in Costa Rica, at 10 degrees north, every slope facing south will receive more sunlight during the year than any slope facing north. So if you are in a hill on the facing to the north, you will need fewer shade trees than if you are in the same slope on the other side of the slope facing south. So it's very important, the latitude, because that determines how much exposure to the radiation you have over the year. Wind and cloudiness are very important. Wind force you to align the trees in lines, and this produces lateral shading. As we showed before, lateral shading is not as optimal for the crop as the regular shading, but this is a condition that is imposed because of the wind. And also the cloudiness. This is an example in El Salvador. It's one mountain that has one side of the mountain, you have wind and you have a lot of sun. So you have this box line planting, and within these boxes, you have the coffee with shade trees of ingas. But on the other side of the hill, you have a cloudiness. You still have the wind, but you don't have the sun. So what you did is you simply open the boxes and get rid of all the inga trees in between, just moving 500 meters from one place to another. You can have completely different conditions of wind and shade and wind and clouds, and this will immediately have implication on the design of the shade canopies. Number 4 is, once you have looked through the objectives of the farmer, look at the plantation condition, look at the conditions of the site, then you start looking at the trees themselves. And here, the most important thing is to have a very good list of the local flora with potential for use as a shade trees in cocoa and coffee. And then you need, for each particular species, evaluate a number of attributes. No? The value, how it is used for goods and services, height is very important. Obviously, some characteristic of the crown, how big is it, the density, the defoliation pattern, the leaf monthly, leaf fall pattern, and so on. Tree heights are very important. Normally, when you talk to farmers, they will say, I have this short tree, has a very dense shade. And if I have the tree is taller, then the shade is lighter. In reality, what happens is that what changes is the speed of the movement of the shade over the ground. When you have a small shade tree, like in the upper figure, and you measure the length of the path of the shade during the day on the ground, you come to one distance. You take the same tree with the same crown size, with the same crown type, and you put it higher, like a taller tree, like in the lower part, the same number of hours of sun movement will give you a longer path. So what it really means is that if you are a cacao tree on the path of the shade, if the tree is short, the shade will move very slowly over your head. So the number of hours of shade per day will be larger than the case when you are under a taller tree. The shade will move faster, and you will have a fewer number of hours of shade per day when the tree is very tall. This has some practical implication, because if I have a tree which is very important for commercial purposes, for example, or for any other reason, but it has a very dense crown and foliage, it better be tall. But if you're gonna work with species like oranges that are short in stature and also have a very dense canopy and foliage, this is a terrible situation. So you have to do something with the planting arrangement if you are gonna combine oranges with coffee or cocoa because this characteristic of the height of the canopy over the ground. Very important for practical reasons. So you can see that there are a number of factors. It's a very large number of factors. And how to put all these factors together, going beyond from this qualitative analysis that we just went through to a more robust, objective, maybe a more quantitative way of putting it. This is something that is really missing in the literature, both in coffee and cocoa. We don't have really good protocol for helping agronomists or helping the farmers to design their system. So we need to do more work on that. There are some general rules. We think they do apply. For example, some people have shown that there is no relationship between biodiversity and cocoa yields. We do know that there is some effect of tree cover on cocoa yields because of photosynthesis. There are some rules of thumbs, like if you have an adult coffee or cocoa plantation, tree cover shouldn't go beyond 30%. If you are a younger coffee plantation, because self-shading in young plantation is very small, then you have to put more shading from the trees. So maybe you will need 60, 70% during the early years of the coffee or the cocoa plant. But as the tree matures and then self-shading increases, you have to reduce this to no more than 30%. This is kind of people that common wisdom. When you turn that into tree sizes and tree numbers, a good measure is basal area. We have seen that cocoa plantation and coffee plantation, the shade canopy should be between 12 to 15 square meters of basal area per hectare. If you go beyond that, then the canopy cover, the reduction in light will reduce the photosynthesis and the productivity of the crop will be affected. So we need to take into consideration these rules of thumbs, but we haven't tested them in a robust way in different agroecological conditions. So there's a lot of work that needs to be done. You can play with the species. You can look for tall tree species that store more carbon. You can look for species with reverse phenology. You can look for species with very small leaves so the transmissibility of the light is larger. You can do a lot of things. There are several functional attributes, functional traits, we'll say now, in the species that can be used to help us in designing better shade canopies to meet specific objectives. No? We're working on some of these ideas. For example, this is a general conceptual model of multistrata system with coffee and cocoa. You typically have the coffee or the cocoa component, we call it K here, and then you have the timber and other tree species like the shade canopy all together on the right side. And you see all these arrows. The numbers and the symbols and the tips of each of the arrows really are differential equations. And we have ideas about what is the nature or at least the shape that this equation should have. We also know about some limits and threshold value that shouldn't go beyond, for example, this like no more than 20 or 15 square meters of basal area. Okay, this is a condition. We know that if I have laurel and then, which is the tall tree, and then I have, let's say, bananas, well, the impact of the banana on the laurel will be lower than the laurel on the bananas. These kind of relationships we know, but what we really have to do now is to put specific functional equations in all those interactions and put to work this system in such a way, optimize the design of the system in such a way that the objective function, which is normally a multi-objective function, is optimized. Like I might be interested in producing a certain amount of carbon because of certification, or amount of timber because of diversification and risk management, or I need to produce a certain amount of food for food security, or I just need a certain amount of money. So we need to do all this modeling, and this is something I am working on. This is my baby now. This is the thing that I'm doing presently. This is my focus of research. We have some tools here in CATIEC. I have, together with other researchers and friends, mathematicians and computer science specialists, designed this software. It's called Shade Motion. You can download it from the internet. Version 4 is in the internet. You can download it. It has an interface in Spanish and English. It can be used to model practically any kind of canopy, different species with different forms, different numbers, no limit on plot sizes. You can run a static simulation or dynamic simulation for, let's say, the whole cycle of the plantation. And it produces shade maps that you can then set condition. For example, if 30%, it's more than 30% hours of shade per year, then it's a problem here. Then I can figure out which trees to prune or to thin, or whether I need to plant more trees. The software allows you to do all this kind of manipulation with the shade canopy. So it's a good thing to try. We have to do a lot of work in education and training, technicians and farmers alike. We did an example in Bolivia with farmers. This is an interview of 200 farmers in workshops, and then we asked how much they knew about the right answer to these 21, 22 variables that we consider are very important in the design of the shade canopy, and we realized that they flunked in most of them. You know, the average response was 50% right, so it's like flipping a coin. There is a great gap in the knowledge farmers have and the agronomists have in terms of shade management and so on and so forth. Most of the work that we have done has been published in this recent paper. You will see the reference there. And also we have some small manual for farmers. It's like a cartoon or comics material that can be used for audio. It can be used for theater representation. And it's very good for really helping farmers to think about all these issues when designing their cocoa shade canopies. So this is basically my presentation. Thank you very much for listening. I'm open to questions. If you have any, we're more than happy to try and answer those.
Thank you so much, Eduardo, for the presentation. We do have a little time left for questions and answers. We probably have 10 or 15 minutes. So I'm going to invite remaining participants to go ahead and send in any questions. Let's go ahead and use the chat function. If you see down below, you'll see a chat bubble, and you can just send in questions. Make sure you select to everyone so that we can all see.
Where is the chat bubble? Let me see more. Find chat. Yeah.
Yeah. Are you aware? Maybe I'll start off asking a question too while we're waiting for folks to send in their questions. Is there any difference or in terms of some of the work in developing robust tools or protocol for planning shade canopies in coffee and cocoa? Is there any difference geographically around the world? I mean, I think most of your examples work is coming from Central America or Latin America, but in terms of maybe other work on cocoa in West Africa or coffee elsewhere, I'm just trying to think. I think there was some land manager or other software used elsewhere in the world. But do you have any insight on that?
I was trying to navigate through this the chat. No, I cannot open the chat room.
Oh.
I was not really paying a lot of attention to you.
Okay.
Sorry
so if you bring your, I think because you're in your PowerPoint, so you need to actually go back and find the Zoom window, and when it's and click on it and get back to it. But you could actually stop. Yeah, if it's of all help, you could stop sharing your screen because. And if that helps you bring back to the Zoom window.
Yeah, now I can see the chat now. I have it on the screen now.
Yeah, I see some questions coming in. My question was just generally if there was you're aware of other efforts or if there is enough geographical difference that tools would be very different in different parts of the world. West Africa for cocoa or elsewhere, cocoa or coffee elsewhere in the world?
Yeah. When you look at the research, let's say for cocoa in West Africa, most of the concern there has been a lot of research looking at what the farmers think are good and bad tree species.
Mm-hmm.
But you don't see a lot of work still figuring out what is the best shade canopy design there.
Yeah.
There's some limitations there, especially with timber, for example, because of the legislation of most of the countries. The timber is owned by the state. It has been changing. For example, in Ghana, it has some changes, but still a lot of work need to be done in terms of the political setting and the legislation regarding timber. So most of the system in Africa related fruit system, no, is the cacao with safu or with fruit species, no. So I think there are some specific conditions. When you go to Asia, mostly they have focused more on, since they have been more intensive systems with more application of fertilizer, they have been mostly oriented towards the use of legume species that are pruned heavily or that are nitrogen fixers, not so much into the diversification aspect. You come to America, we typically have this mixed system where you start with legume species like ingas or gliricidias or erythrinas, and then after some 5-10 years, then you start removing some of these legume species to plant some fruit trees like avocados and oranges and some palm trees, and then some natural timber regeneration. So what you see is the reduction of the initial species, legume species that were planted, and then the evolution towards a more mixed system where you have typically 40, 50 timber trees per hectare, maybe 10, 15 fruit trees per hectare, and then the remaining are some of the ingas and the erythrina that were planted at the very beginning of the plantation. So different area has like different ideas, different evolution of the shade canopies, but I don't see there is a coherent analysis, the way of analyzing the different system in the different region, and it's really a great room for improvements there.
Right. So the general, I guess, message that there's a real need for additional work and research to advance some of these more robust quantitative methods for designing the shade canopy. And as you mentioned, difference in geography is not just in terms of climate and the ecological conditions and cultural habits, but the regulatory regime in each country is really going to impact what farmers really have for options or decisions, especially when it comes to timber. Yeah.
Exactly. And then this agroecological part, it would be interesting to see gradient. Okay, if I am in West Africa, what if I move from 1,000 millimeters of rainfall to 2,000 millimeters? What are the adjustments that I need to make? What changes are needed, depending on the soil, water and soil. I think will be the critical ones to do. We don't have really a good systematic analysis of all these gradient as they relate to the design and the management of the shade canopy. I have some questions here.
Yeah, a number have come in, Eduardo. So thanks for addressing that. Shall we start with Andrew Timko's question? Can you see that one? Has any of the research, particularly the soil nutrition and carbon acquisition studies, has any of this been studied in conjunction with soil biology? That's his question. Then,
really not much. As in many other aspects, soil still is like a big black box. Now they have better methods to study the root biology, root distribution, and soil biology itself. Not much. Probably most of it has been related. The few studies that I know most related to like soil health. Looking at some organisms like macrofauna and some functional characteristics of the soils, like respiration and so on, like that. But I think it's an area that is really not very well represented in the literature. So there's a lot of work that needs to be done there. And now with carbon and nutrients, very important if we can really do more work on this related to soil biology. And and not only because of the soil and carbon, but also because of diseases, no? The suppressive impact of soil biology on some root soil-borne diseases like Phytophthora, no? Which are so important, or Roselinea, or some of these soil fungus that are really detrimental, or nematodes that are very detrimental to the productivity of the crop. I think this is a whole area of research that has not really been explored enough.
Yeah. Well, thank you for addressing that. Eduardo, if we scroll down a little bit, I see a question from Ute. And Ute is asking, what do you think about successional agroforestry compared to other agroforestry models?
Yeah, here successional agroforestry, I would say that successional, most of the agroforestry systems are really successional, no? Because farmers normally start their cultivation cycle with an intercropping phase. Normally, during the early stages of the plantation, you intercrop it with short-term crops like cassava, with maize, definitely bananas, and so on and so forth. And then you have the crops itself. There's a school of thinking in successional agroforestry system that come from Brazil with this German researcher Gotz. These systems, to me, are very interesting because they really try to mimic the successional process that you see in natural ecosystem. You start trying to saturate the site with a sequence of species over the entire life cycle in such a way that you are somehow mimicking the successional change in botanical composition and functional traits along the successional time gradient. I think that's right, because the closer you get to the natural processes that are typical of the forest ecosystem and the site, this is correct to do.
Yeah, thanks.
My main problem has to do with the financial aspect.
Oh,
because it really demands a huge amount of seed, to keep the time saturated, and it has some implications also for the marketing and the value chain aspect of it, because it is very good for subsistence farmers, I would say, but when you come to the economics, you want to be more commercial. You cannot produce that many number of tree crops or food crops in small quantities because all the logistics and all the value chain aspects related to the marketing don't get so easy, So I think there's room for improvement of how far you natural ecosystem in mimicking it, and what are the restrictions imposed by the economics of the selection of the species to mimic the successional process.
Yeah, thanks. You mentioned the gentleman in Brazil. It's Ernst Goetsch, and one of our participants sent us a link. If you can see down at the bottom of the chat box, he's got this Ernst Goetsch thing called syntropic farming, and the link is there. It's Agenda Goetsch, GOTSCH.com, and that's the.
Yeah, Ernst. Yeah, I know him in person. Yes.
Yeah, right. Yeah, I think we've engaged with him in the past too. Eduardo, we're coming up on just a little about the hour. There are two more questions that are asked. Maybe we'll just try to quickly address the two remaining questions if we're able. And one is from Alan Hines and asks if you're able to share some thoughts on shade design related to crop diseases.
I think it has to do a lot, has to do with wind movement. Guts Schroth has worked a lot on this disease part. The problem with diseases is that it's very difficult to come up with one single solution that fits all, because normally you have different disease complexes, and the disease complexes, different disease species or pathogens or pests have different requirements for the dispersal, the infection, and so the different stages of the infection cycle are affected differentially by the conditions created by the shade canopy. It's a very difficult area to optimize because the complex of pests and diseases have very different requirements or conditions that they would favor or hamper or adversely affect the development of the disease. And the different stages of the infection cycle also are affected differentially by the different stages of the shade canopy. So combining all these things together in an optimal system has proven very difficult to achieve. But I think in general, there are some rules of thumb, For fungal diseases, you want to open the canopy, you don't want a stagnant microenvironment. These kind of things are really general, but don't apply to all the diseases itself. Some trees some crops, some diseases respond to low shade, others like high shade, and so on and so forth. So it's really very difficult, this is Heinz, changes in shade management respond to external factors of low crop prices. Yes, definitely. We have seen, if you look at the literature in Africa, for example, the recommendation for the diversification and stability of the farming system, they're proposing a mid-diversity agroforestry system. You don't want to go very diverse, not very simple, something in between, combining timber, which requires a lot of adjustment in the legislation and so on, and also with the fruit, but then you have to develop better the market value chain aspects of the fruit tree. So definitely you can use this, and there are some changes that you can see in the farmers in the design to respond to these factors. The presentation is available, I understand.
So just following up on some of that, a participant working with cacao in the Dominican Republic comments that she has been trying to incorporate the gauche method, but a lot of concerns about water demand in the system. And following up on disease concerns, Ryan Smith mentioned that in Ecuador, the development of new cacao varieties, most of which have shown high production and are disease resistant when grown in full sun. And so he's asking about, is anyone working on developing varieties which would have high production and are adapted to more shaded biodiversity-friendly systems? And after that, are you able to see that? Ryan Smith's asking.
I think the Ryan and some the Bennett, also
also asking about optimization.
Yeah, you can. I mean, shade motion, really what shade motion gives you is a shade map. It tells you in every point of this particular plot how many hours of shade I'm getting because of the tree population that I have in the plot. And you can relate this value to the performance of the crop, saying, well, if I have 50% of the time this under shade, this particular site where I have this cocoa or this coffee plant, there's some trouble here. There is no specific model related to biodiversity, but you can use this maybe to test different species with different biodiversity value and see how changing the species to achieve your biodiversity goals can also be done in such a way that you respect the threshold values that are necessary for a good productivity of the crop itself. I think indirectly it could be used to that. We're working in biodiversity. This is something that really interests us, yes. Then Ryan, hypothesis on those with high production, disease resistant, well in full grown. About the cocoa itself, coffee. There has been a lot of more work in the genetic improvement of the coffee than in the cacao itself. In coffee, we have varieties. Most of the commercial varieties are F10 or F12. So there's have been 10 to 12 different cropping cycles or breeding cycles to develop these varieties, and some of them have been, look for productivity and then photosynthesis optimization and so on and so forth. In cacao, we haven't gone that far. What we really have in the cacao genetic part is a number of clones, maybe in all the collection, maybe it's estimated about 12,000 clones altogether. And out of those, maybe 5% have been used in the breeding system, breeding programs. We are now looking at a big change in the breeding system in cacao because we were moving from using hybrids, from intercronal process in the commercial plantation to the use of the clones, either the parental clones or individuals that have been selected from the crosses of those clones and then propagated asexually and have monoclonal plantation with higher productivity. But in general, there are still very limited C3 plants, you know, with a low saturation value of 40% of line intensity saturation is achieved even with these high yielding clones. It seems that most of the value really relays on the way internally how these particular clones allocate carbon to vegetative parts or to fruits. So there hasn't been tested really a lot, you know, that how much shade you can have with very high yielding clones. But I always challenge, especially the Ecuadorians that always, you know, proposing their CCN 51 closed monoculture, 1,600 plants per hectare, almost a ton of fertilizer and 2 tons, 3 tons of yield. I always challenge them to find a tree density which is low enough not to affect yields of the high yielding clones, but still high enough to be a significant source of income and diversification of income to this farmer. I think there's a lot of room still in Ecuador high intensive production monoclonal system to work with shading system without really affecting the productivity of the clone itself.
Yeah. Sorry. Thank you, Eduardo. We are a bit past the hour, but what do you say, Eduardo, if we finalize with just one last question? If you've seen the question from Vivian Valencia and her question about whether you've observed farmers modifying shade management factors in response to external factors, such as low crop prices, pests, certainly for coffee, and climate change.
I think I try to respond to that, but yeah. My point again is yes. I think the change has occurred. For example, in Costa Rica is a very good example with coffee prices. No, in coffee prices we move from typical when the prices are very low, and we have had several crises of low coffee prices like we are now. In this particular moment, prices are very low and they stay low for a long time. If the low prices low for a long time, people start thinking about how to improve the income from this particular plantation. In Costa Rica, what happened was there was a change from the typical legume shading system based on ingas and erythrinas to use of timber, high value timber using financial instruments like credit from the government, legislation, subsidies to help farmers to transform the shade canopy from legume species to timber species. And many studies have shown that you can do this change without really affecting the productivity of the crop itself, because when you change from erythrina or inga or glycidia to timber species, you still have this high transmission level of organic matter to the soil in terms of litter, even with the timber trees. And so you still get some of the benefits of soil cover, nutrient transfer to the soil via litter fall, and so on and so forth. So there are examples. In Africa, I was mentioning this issue of transforming the existing no shade system, typically in cacao in Cote d'Ivoire, transformation into a low shade system with not so complex agroforestry system based on timber and fruit. So I think there are changes now taking place because of the prices. You know, the crisis on prices. Climate change will also affect. People has also been trying to incorporate more carbon into the system to be able to certify their production and then get better market prices or better market or more secure market, and so on and so forth. So external factors, mostly economic factor, can have and are having, I think, not at a rate that I would like to see, impacts on the way you design the shade canopy.
Well, thank you, Eduardo, for addressing that question, and thank you so much for being with us today and for an excellent participation and staying around for a discussion. That concludes our presentation today. Again, this has been a presentation in the Agroforestry in Action webinar series, a production of the Center for Agroforestry at the University of Missouri. We host webinars about monthly, and you can see more information about webinars past and future on the Center for Agroforestry.org website. This presentation has been recorded and will be posted for future on-demand viewing. And again, you can check the links on Center for Agroforestry.org. Thank you so much to everyone for joining us, and thank you to Eduardo Somarriba, and we'll see you again next time.
It was really a pleasure. Thank you, everybody, and goodbye. Now we are connected. Anything we can continue this conversation over the email or Skype or whatever. Well,
yeah, hold on one second. I'm going to stop the recording here, and let's see if there's a few folks I think who